learn together, pass together, grow together. So, today we learn the OSI versus the TCP IP model. But wait, why are we even learning this? Here's the thing, I hear all the time from people starting out in networking that do I really need to know the OSI model? Like, I can't just memorize the layer for the exam and move on. Old myself wouldn't said, yeah, sure, cram it and forget it. But I'm telling you, the OSI model is different. This isn't a trivia you toss out after test day. You actually use this thing day in, day out as a real network engineer. When the POS system goes down at 7 a.m. at example server, where you are the network engineer and the some machine is the only thing keeping the you and the staff sane. You will be running through these layers in your head. Trust me on that. So let's talk about what these models actually are and why are there and why there are two of them floating around. Two models, one job. Both the OSI model and the TCP IP model do the same things. They describe how network communication works. Think of them as blueprint, not the network itself, just a description of how the network behaves. The OSI model breaks communication into 7 layers and the TCP IP model condenses that into 4 layers. That's really the core difference. And here is the part that confuses everybody. When you use the OSI model to describe TCP IP, right? I know that sounds ridiculous, but stick with me. TCP IP won the protocol war, not because it was better, but because it was ready. OSI was actually the more robust, more detailed protocol, but TCP IP shipped first. The internet builds itself on top of it, but here we are that OSI become the model we use to talk about how things work. Even through TCP IP is actually what's actually running underneath and why the layer matters. There are three real reasons network engineers live and breathe the OSI model. Number one is common language. When something breaks and you are on the phone with another engineer, you need to be able to say, this looks like layer 3 addressing issue and have them immediately know what you mean. That's an IP problem. That precision saves time without the model. You're just waving your hand and saying, the network's broken, which honestly helps nobody. The second one is troubleshooting and design. The layered approach means you can isolate problems. Is that the cable? That's physical, layer 1. Is it an IP config issue? That's layer 3. You don't have to tear apart the entire stack when something goes wrong. You start at one layer, rule it out, move up or down. It's clean, it's methodical. Methodical. Okay? Now, the third one is interoperability. This one's big because vendors design equipment to specific layer standards. A Cisco access point and an Aruba access point can talk to each other. The standard 802.11 is what defines wireless at layer 2. And every vendor buildings to that standard means all their gear plays nicely together. That's the layered model doing its job. So the confusing part is the OSI model splits into two zones, and once you see it this way, it clicks. The top three layer, which is application, presentation and session layer, are really about the application format and manage data before it hits the network. As a network engineer, we mostly hand wave at those and say application team's problem. Which is why the TCP IP model just smashed all three into one big application layer and call it a day. And the bottom 4 layer of OSI model, which is transport, network, data link and physical, that's where we live. That's where the real networking happens. And here is the big cool part that a modern TCP IP model actually mirrors those same bottom 4 layers into OSI almost exactly. The original TCP/IP model lumped data link and physical into one layer, which is called link, and people hated it. So they updated it and now it lines up, which is application, transport, network, data link and physical. Okay, what you need that know the 7 layers, know their order and especially know what the bottom 4 layer do. because that's where we spend most of our time in this next lesson. Okay?